Hello everybody, this is for Algebra 1, 6.1 lesson. Ordering information here. 6.1, solve linear systems by graphing. Here is the standard teachers. Bell work, solve the inequality, graph the solution. Tell whether the graph's two equations are parallel. Students, as you walk in the classroom, do this spell work. Explain your reasoning. Are these two lines parallel? Then explain. If you need more room, staple an answer sheet to your classwork sheet. Solve linear systems by graphing. You've graphed linears. You will graph and solve systems of linear equations. So you can analyze craft fair sales as in example 33. I believe that is in of this lesson. A system of linear equations are simply a linear system consists of two or more linear equations in the same variables. Equation 1 and equation 2, so a solution of a system of linears and two variables is an ordered pair that satisfies each equation in the system. One way to find a solution of a linear system is by graphing. You could just graph these two equations. And then where these two lines intersect, that would be your solution. A solution found using graphical methods should be checked algebraically. And then here is our vocabulary: a system of linear equations, solution of a system of linear equations. This goes in your notebook, students, so make this entry as page 2, lesson 6.1. So when I teach this in a classroom, I check notebooks on Friday to make sure students are taking notes. And they get a notebook grade. This is 10 points here. Another notebook entry here. Slide number 3 on 6.1. Check the intersection point. So, use the graph to solve the system, then check your solution algebraically. Equation 1, equation 2. Here is where they intersect, where these lines intersect. Right here is the intersection. It looks like 4, 2. When x equals 4, y equals 2. Oh, 3, 2. Wait a minute. What am I looking at here? 1, 2, 3. 3, 2. Okay. 3, 2. Substitute 3 for x and 2 for y in each equation. So, here's our two equations. We're going to substitute now. 3 and 2, we get 7 here. And then over here, what do we get over here? 7 equals 7, and over here we get 5 equals 5. So it checks. 3 times 3 is 9, minus 4 is 5. Whoop, let me go back. You have to catch that one on your video. I can't go back in my recording. So anyways, here, solve the linear system by graphing, check your solution. So graph these two lines. Students, this is your independent practice. Graph these two lines. Where they intersect, that will be your solution. Solve the linear system by graphing, check your solution. Here's the graphs. They intersect here. The intersection is at 1, 5. You plug that back into your equations up here. We're going to substitute 1 and 5. We get 0 on equation 1. And then for equation 2, 10 equals 10. So it checks. It checks algebraically. This is the algebraic check that checks the graphical method. 1, 5 is solution of each equation. It is a solution of the system. Page 8. Now we're going to go through, we're going to use a graphing calculator. y1 equals 5x, and then y2 equals negative 5x plus 10. Here is the graph using a TI-84. And we get this as a solution when x equals 1, y equals 5. Types of linear systems. In example 1, a linear system has exactly one solution. A linear system that has exactly one solution is called a consistent independent system because the lines are distinct, are independent, and intersect, are distinct, and they intersect, are consistent. You will solve consistent independent systems in this chapter, and you will also consider other types of systems. Now define consistent independent system. Students, put this in your own words. Or you can copy it from the previous page of your classwork. Put this in your notebook, page 10, lesson 6.1. Classwork, page 11, key concept. Solving a linear system using graph and check. Graph both equations. Estimate the coordinates of the point of intersection. Check the coordinates algebraically by substituting into each equation of the original linear system. Example 2. Use the graph and check method here. Solve the linear system. Here is our linear system with equation 1 and equation 2. So we graph both equations, and we come up with our intersection here in quadrant 4. Estimate the point of intersection. The two lines appear to intersect at 4, -3. 4, -3. So now we're going to check that algebraically. Check whether there's a solution by putting those values into the original equations. Equation 1, equation 2. We'll put in 4, -3 back into the originals. -7 equals -7. -8 equals -8. It checks. Because 4, -3 is the solution for each equation, it is a solution of this linear system here. Now, into our guided practice, solve the linear system by graphing. Check your solution. You do the same thing down here, students, on your own. Solve the linear system by graphing. Check your solution. Here's equation 1. Then we're going to solve here for y. Slide 16, and then here is our equation 1 put into slope-intercept form. And then equation 2 here is going to be in slope-intercept form. Here's your slope, -2. Here's your intercept is 4. So these are the two lines here that we graph. We have to solve for y, and then we can graph now from this slope-intercept form. Here's our graph here. This is the point of intersection at 1, 2. This is our solution for this system of equations right here. So now we're going to check. We plug in 1, 2, and we get 3 here for equation 1. Equation 2, 1, 2, we get 4 equals 4. It checks algebraically. Because the ordered pair 1, 2 is a solution, it is a solution of the system. And then here, using a calculator, here it shows the intersection here. You'd have to like zoom in to really see it. And this is done by Animated PowerPoint Math Video at AOL.com. If you want to order this PowerPoint, contact me at that email and I'll set you up. Thank you.